Now that Ali's explained how we do find exoplanets today, I'm going to talk briefly about how we did find exoplanets in the past and just give a brief history of the idea of exoplanets and their discovery. To start, the idea that other worlds existed besides our own Earth, besides our own solar system, well, that idea has actually been around for a few centuries. The earliest known recorded thought regarding the idea of exoplanets or other worlds, that came from the Italian philosopher Giordano Bruno back in 1584, when he pondered the thought that this space that we declare to be infinite, that infinite space, there must be an infinity of worlds inside it. And those infinity of worlds would be just like the ones that we know here, our Earth and our solar system. Isaac Newton was a prominent scientist who actually agreed with this idea that there has to be other planets and other worlds outside of our own solar system. And I'm sure there were many, many other scientists and astronomers in the 16th, 17th, and 18th centuries that also agreed that this must be the case. However, of course, back then, having the wrong ideas about space could potentially get you exiled and or killed. And so I'm sure many of them just decided to keep their ideas to themselves. Getting into the early 20th century, there started to be some claimed detections of exoplanets, none of which could be confirmed directly due to the poorer instrumentation and accuracy back then than we do today. The very first detection, confirmed detection of exoplanets, that occurred in 1992, when two scientists discovered two exoplanets that were orbiting around a millisecond pulsar, a rapidly rotating neutron star. And in fact, a few years after this discovery, when they were looking back at the same star, they found that there was actually a third planet, a really tiny one that they weren't able to find the first time, that was also orbiting around along with the other two. Once we found these two planets around one star, well, there was nothing special about this particular star, and so we knew that there must necessarily be other planets out there in other solar systems that we should be able to find. And that started a large amount of activity and excitement towards looking for these exoplanets. And in fact, once that began, we were able to sort of retroactively confirm some of the claimed detections that had happened earlier in, say, like the 1980s. Now that our instrumentation was a little bit more powerful and our methods were better. The Kepler Space Telescope, which was in operation between 2009 and 2018, is probably one of the most, if not the most important probes that we've used to look for exoplanets. During its lifetime, it actually found and detected over 2,600 out of the 4,000 plus exoplanets that we have discovered, a very large percentage. And then in 2018, it ran out of fuel, and that was that. No more Kepler Space Telescope. Every single one of these exoplanets it found detected using the transit method that we talked about earlier. And that gets us to today, where we now have found 4,000 plus and counting exoplanets. So let's meet some of them. To start, let's meet Proxima B. What's so special about Proxima B? It happens to be the closest exoplanet to Earth. It's just 4.2 light years away. Cosmically speaking, that is an incredibly small distance. In terms of our ability to actually ever get there, well, we've got a long way to go. Proxima B is of a similar size to Earth, but it does orbit around its star a lot faster than we orbit around our sun, 11 days compared to 365. Now let's meet Kepler 78b, the lava world. This planet was detected using the transit method, the Kepler Space Telescope, and this planet orbits its host star at a radius of 550,000 miles. That is incredibly tiny. It is actually 40 times smaller than the radius of Mercury's orbit, which is already pretty darn small. This leads to a very interesting conundrum that we actually have no idea how this planet got there in the first place. Why is that the case? Based on our understanding of when this planet would have formed, its host star that it orbits around is a lot smaller today than it was then. And so back when this planet would have formed, its host star was much bigger than that 550,000 mile radius, which means that Kepler 78b would have formed inside of its host star, and that is not possible. So to this day, we're actually not entirely sure how this planet got there in the first place, but we do know that just in a billion years or 2 billion years or so, it will definitely 100% fall into its host star and be disintegrated. Now let's meet TRES 2b. What's so special about TRES 2b? This exoplanet, also discovered using the transit method with the Kepler Space Telescope, this is the darkest known exoplanet that we have found. It reflects only 1% of its light, compared to 10% or greater for other exoplanets. What are some potential explanations for that? Well, one of the leading explanations is that it might be due to a very high concentration of sodium and potassium in the atmosphere, which would just absorb the light and not re-emit it for us to see. But it's still a little bit confusing because we know of other planets, of other gas giants that have sodium, that have potassium in their atmospheres, but we don't see them anywhere near as dark as TRES 2b. And lastly, let's meet 55 Cancri E. Now, this planet was not discovered with the Kepler Space Telescope. It was discovered using the radial velocity method that we talked about earlier. 55 Cancri E, as far as we know, is mostly made of carbon, and it has a surface temperature of around 5,000 degrees Fahrenheit. And so you can put two and two together. It's mostly made of carbon. It's got a really high surface temperature, and there's going to be intense pressure. So what does that mean? It means that 55 Cancri E could very well be made of diamond. And if that's the case, well, then we can calculate about how much 55 Cancri E would be worth. And it turns out that it would have an estimated worth, if it's made of diamond, of about $26 nonillion, which, to put into perspective, is about 400 quadrillion times the entire GDP of our planet Earth. But again, we're not getting to this planet anytime soon, so don't get any ideas. But there are 4,000 plus exoplanets, and it would take forever for us to go over and talk about each one individually and its characteristics. So instead, Ali is now going to talk about other ways that we can group and classify these exoplanets and what they're like.